Hello everyone, good evening. Here we shall solve some more JEE Mains previous year questions from the chapter Gravitation. Any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them. And please install our Sapience education application also, where we shall upload some important questions on every chapter, which shall be obviously helpful for exam. So here it is told that the time period of a satellite revolving around Earth in a given orbit is 7 hours. The time period is 7 hours. If the radius of the orbit is increased to 3 times its previous, so r is increased to 3r, then the approximate new time period of the satellite, if T1, the new time period will be how much? So here we can apply the Kepler's law of periods, which tells that T square is proportional to R cube. So I can say that T1 by T2 whole square, T1 square by T2 square equal to R1 cube by R2 cube. So it means T1 square by 7 square, that is equal to the new radius, which is 3R whole cube divided by the initial radius of the orbit, that is R cube. So this would be T1 square would be equal to 7 square into 3, 3, 0, 9, 27. 7 square into 27. So T1 will be equal to 7 into 3 root 3 hours, which is equal to approximately 21, since we get 21 into root 3, which is 1.732 hours. So T1 will be approximately 1.732 into 21. 0.732 into 21, which is approximately 36.37 hours. Which is approximately 36 hours. So the approximate new time period of the satellite will be 36 hours. So option B is the correct answer. And here it is told the escape velocity of a body on a planet A is 12 km per second. Escape velocity is 12 km per second. Escape velocity of the body on another planet B. Escape velocity on another planet B, whose density is 4 times and radius is half of the planet A. So the escape velocity of on another planet will be how much? Whose density is 4 times and the radius is half of the planet A. So if the density of the planet is rho, then the density of the planet B, that is 4 times of rho. And the radius is half of the planet. So if the radius of planet A is R, then the radius of planet B is R by 2. So its escape velocity will be R. So we know that escape velocity that is given as root 2 g1 by R, so which is equal to root 2 g into 4 by 3 pi r cubed into rho by R. This will cancel. So we can say that this thing is constant. So the escape velocity is directly proportional to sigma into r square dv. So square root of rho r square, right? Which means escape velocity is proportional to root over rho into r. So therefore, escape velocity in A by escape velocity in B by escape velocity in A, that is equal to root over density of B into radius of B divided by root over density of A into radius of B. Therefore, the escape velocity in planet B divided by escape velocity in planet A, which is 12 km per second, that is equal to root over rho B that is 4 rho by rho A that is rho into RB that is R by 2 by RA that is R. Therefore, dP by 4 that is equal to root over 4 into 1 by 2 is equal to 1. Since y root over 4 is 2, so 2 and 2 will cancel out. Therefore, the escape velocity in B also will be 12 km per second. So it will be option A is the right answer. Then it is told that water falls from a 40-meter high dam at the rate of 4 into 10 power 4 km per hour. Water falls from a 40-meter high dam at the rate of 9 into 10 power 4 kg per hour. 50% of the gravitational potential energy can be converted into electrical energy. Using this hydroelectric energy, number of 100-watt lamps that can be lit is the gravitational potential energy that is equal to mgh mgh. So that will be the gravitational potential energy that is obtained per hour. That is mgh. M is 9 into 10 power 4 into g, that is 10 into height, that is 40 meters. So 4 9 are 36. 36 into 10 power 6. This much joule. So this much joule per hour. So therefore, 50% of this can be converted into electrical energy. Therefore, the electrical energy output, electrical energy that is obtained per hour, that is equal to 36 into 10 power 6 into half. Hence, since why 50% of this can be obtained as electrical energy. So it is 2 18 to 36, so it is 18 into 10 power 6 joule. So now, therefore, the electrical power output, electrical power that is obtained, that is equal to 18 into 10 power 6 divided by 3600 seconds. That's why we need the power, which is equal to energy by time. So this will be 18 to 36, so 200. So this will be 10 power 3, I can say 1000 into 10 power 3 watt by 200. So 200 5 is 1000, so 5 into 5 kilowatt or 5000 watt. So therefore, the number of 100-watt lamps that can be lit, number of 100-watt lamps that can be lit, that will be equal to 5000 watt divided by 100 watt. So that would be equal to 50. 50 10 100 watt lamps can be lit. 50. So option B is the correct answer. Then it is told two objects of equal masses placed at a certain distance from each other attracts each other with a force of F. The one-third mass of one object is transferred to the other object, and the new force will be. The two objects are of equal masses and they are kept at distance r, I can say. They are kept at a distance r from each other, then they will attract each other of mass n. So the force acting on each other is F. So I can say F is equal to G m square by R square. Now it is told that 1/3 of mass of one object is transferred to the other object. So here I will have 2m by 3, here I will have 4m by 3. Since why from here m by 3 mass will go to this mass. 1/3 mass is transferred to the other object. So here I will have m minus m by 3, which is 2m by 3, and here I will have m plus m by 3, which is 4m by 3. But the separation is not changed, so the separation is R only. So therefore, the new force that will be equal to G into 2m by 3 into 4m by 3, G into by R square. So this will be equal to G into, what is the 8 by 9 m square by R square. This will be equal to 8 by 9 into G m square by R square. So it should be equal to 8 by 9 times F. 8 by 9 F. So option C is the correct answer. Then it is told that two planets A and B of equal mass are having their periods of revolutions TA and TB such that TA equals to 2 TB. There, these planets are revolving in circular orbits of radii RA and RB respectively. And which of the following would be the correct relation of their orbits? We can say that we know that T square is proportional to R cube, which is the Kepler's law of periods, which tells that square of the time period of revolution is directly proportional to the cube of the uh, radius of the orbit. So therefore, here I can say TA square that is proportional to RA cube, and TB square means the square of the time period of revolution of planet B that is proportional to the cube of the orbital radius of planet B. So it is RB cube. And therefore, I can say okay, so here would be then TB. So 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 here it is told that TA equal to 2 TB. I can say TA square equal to 4 TB square. So we can say that TA I can say that is some constant K into RA cube that is equal to 4 into a constant K into RB cube. So K and K will get cancelled. So RA cube that is equal to 4 RB cube. So option C is the correct answer. And here it is told that the distance of the sun from the earth is 1.5 into 10 power 11 meters, and its angular diameter is 2000 seconds. Now, when observed from the earth, the diameter of the sun will be, this is the sun, this is the earth, angular diameter observed from the earth, angular diameter of the sun, this angle theta, that is 2000 seconds, 1000 arc seconds. Then the diameter of the sun will be, let's say the diameter of the sun is capital D, and the it, the distance of the sun from the earth, the distance of the sun from the earth, let's say that is x, or let's call it as d. So therefore, I can say that d into theta that is equal to d. So therefore, the diameter of the sun that you have to find, so d into theta. Now this theta we have to use it in radians. radians. So this will be D is 1.5 into 10 power 11 meters. So this will be 1.5 into 10 power 11 meters into theta, that is 2000 seconds. So 2000. So 1 second is 1 by 3600, 1 by 3600 degrees. You can say this by 3600, this much degree, and 1 degree we know that is equal to pi by 180 radians. So this into pi by 180 have to be this much meters we will get. This would be 1.5 is 3 by 2 into 2000. So 0 0 will cancel. So that is 20 by 36 into pi by 180 into 20 by 36 into pi by 180 into 10 power 11 meters. So this will be 2 tens are 20, 0 0 will cancel. So 12 3 are 36. This is pi by 12 into 18 to 10 power 11 meters. This would be approximately 5 divided by 2 into 18 is 0.0145. This is approximately 0.01454 into 10 power 11 meters, or I can say it is 1.454 into 10 power 11 minus 2, that is 10.9 meters. So option C is the correct answer. When it is told 4 spheres, each of mass m, form a square of side D as shown in figure. A fifth sphere of mass small of mass capital M is situated at the center of the square. The total gravitational potential energy of the system is the total gravitational potential energy of the system is. So this is the total gravitational potential energy. It will be Gm square by side length is D. Gm square by D square plus will be Gm square by D square plus Gm square by, this will be root 2D, root 2D. Okay. Potential energy, so Gm. So this will be minus G. The first one will be brought from infinity, so then work done is 0. Then the second one will be brought from infinity, the work done will be minus Gm square by D. Then keeping these two, the third one will be brought. This will be minus Gm square by D minus Gm square by root 2D. Then keeping the three of them, fourth one will be what? So that will be minus Gm square by D into 2 minus Gm square by root 2D. And the fifth one will be what? It will be minus Gmm by root 2D by 2. So D by root 2, D by root 2 into 4. This way, four small m masses are there. So therefore, this will be equal to minus 4 Gm square by D and minus 2 Gm square by root 2D minus 4 root 2 GMM by D. So I can take minus G, yeah, this is minus 4 GM square by D. So we will take minus GM by D as common. Then inside we will have 4 plus root 2, 4 plus root 2 into small m plus 4 root 2 capital M. That means that option A is the correct answer. Then it is stored in statement 1, the law of gravitation holds good for any pair of bodies in the universe, which is true. And the weight of any statement 2 is the weight of any person becomes 0 when the person is at the center of the earth, which is also true. Since so the value of G at the center of the earth will be 0. So both statement 1 and 2 are true, so option A is the correct answer. Then it is told in the assertion, if we move from poles to equator, the directional acceleration due to gravity of Earth always points to the center of Earth without any variation in its magnitude, which is false. Since why there is an effect of the rotation of the Earth. At equator, the directional acceleration due to gravity is toward the center of the Earth. So the reason is true. Assertion is false. So assertion is false and reason is true. So option D is the correct answer. It is told the variation of acceleration due to gravity with acceleration due to gravity G with the distance r from the center of the earth is correctly represented by. So that will be obviously option A, since why you know that the value of G with r, the value of G at a depth, so the value of G is given as you know, it is Gm by r cube into r for r less than less than or equal to 1, and it is Gm by r square for r greater than 1. So it means there is a from 0 to r, it will be a straight line, and then it will uh, decrease as a function of 1 by r square after for more than r. Option A is the correct answer. Then it is told the height of any point P above the surface of the earth is equal to the diameter of the earth. The value of acceleration due to gravity at point P will be, there is a height of any point P above the surface of the earth is equal to the diameter of the earth, which is 2r. So the height is 2r. Height is 2r. The value of acceleration due to gravity at point P, which is G dash. So the value of acceleration due to gravity at point P will be, height of any point P above the surface of the Earth is equal to the diameter of the Earth. The rate of acceleration due to gravity at point P will be. So this will G will be equal to G into R square by R plus H whole square. So this 2R plus 2R whole square. So this is equal to G R square by 3R whole square, which is 9R square. So that is equal to G by 9. So option D is the correct answer. And here it is told the distance between Sun and Earth is R. The distance between Sun and Earth is R. The duration of year if the distance between Sun and Earth becomes 3R. So we know that T square is proportional to R cube. Is the Kepler's law of period. So I can say that T1 square by T square, that is equal to R1 cube by R cube. So T1 square is equal to R1, that is 3R by R whole cube into T square. T is 1 year, so 1 year whole square. So this is 27, so T1 square will be equal to 27 into 1, so 27. So T1 will be equal to 3 root 3 years. So the duration of the year, if the distance between Sun and Earth becomes 3 years, will be 3 to 3 years. Option D is the correct answer. It is told the approximate height from the surface of the Earth, at which the weight of the body becomes one-third of its weight on the surface of the Earth is. So the weight W dash, I can say weight on the surface into R square by R plus H whole square. So W dash is given as W dash is the one-third of the weight. Since we know that G dash is equal to G into R square by R plus H whole square, so the weight also will be mg dash. So mg dash equal to mg, which is the actual weight on the surface, into R square by R plus H whole square. So W by 3 is W into R square by R plus H whole square. So W cancels. So R square by R plus 3 by R plus H whole square. If we take square root on both sides, then we will get R by R plus H, that is equal to 1 by root 3. And say R plus H by R, that is equal to root 3. And say 1 plus H by R, that is equal to root 3. So it means H by R, that is equal to root 3 minus 1. So the height H will be equal to root 3 minus 1 into R. So therefore, the required height from the surface of the Earth, that is root 3 minus 1, which is 0.732 into the R, that is 6,400 kilometer, which is 64 into 73.2 kilometer approximately. So that value is 64 into 73.2, that is approximately 4685 kilometers. So option B is the correct answer. So this is actually 4684.8 kilometer, which is approximately 484685 kilometers. Then here it is told if the acceleration due to gravity experienced by a point mass, the height h above the surface of the earth, acceleration due to gravity experienced by a point mass m at a height h above the surface of the earth is same as the acceleration due to gravity at a depth alpha h from the surface. Value of alpha will be h is much less than r. So I will say that g dash that is equal to g into 1 minus 2h by r e, since by h is much less than re, and that will be same as at a depth d, which is alpha h. So it is g into 1 minus d by r e. So d is equal to alpha h. So then the value of alpha will be h. Therefore, I can say g into 1 minus 2h by re, that is equal to g into 1 minus alpha h by re. So obviously, alpha will be equal to 2. Alpha will be equal to 2. So alpha will be equal to 2. Then two satellites S1 and S2 are revolving in circular orbits around a planet with radius R1 equal to 3,200 kilometers and R2 equal to 800 kilometers respectively. The ratio of speed of satellite S1 to the speed of satellite S2 in their respective orbits will be 1 by x, where x is. So therefore, speed of the satellite 1 by speed of the satellite 2, that is equal to 1 by x, then x we have to find out. So the orbital velocity we know that is equal to root over gm by r. M is the mass of the planet and r is the orbital radius. So therefore, I can say v naught is inversely proportional to the square root of the orbital radius. So I can say v1 by v2, that is equal to square root of r2 by square root of r2 by r1. Will be equal to square root of r2, that is 800 kilometer by 1200 kilometers. So this will be 0 will cancel, 4 into 32, which is 1 by root 4, which is 1 by 2, which is equal to 1 by x. So x will be equal to 2. So the value of x is 2. And here it is told 4 particles, each of mass m, move along a circle of radius r under the action of their mutual gravitational attraction as shown in the figure. The speed of each particle is speed of each particle is four particles, each of mass m, move along a circle of radius r under the action of the mutual gravitational attraction. Speed of each particle is, so this mass m will be attracted by this mass also, by this mass m also, and by this mass m also. So therefore, then the resultant force will be equal to the centripetal force. So I will say that this force will be equal to, this is r, this is r, this will be root 2r. So this force will be equal to gm square by root 2r whole square, that is 2r square. This force will be the same. Let's call it as F1. This is also F1, this is also F1. So F is 90 degree, so this is 45 degrees. So F1 sine 45 and F1 sine 45 will get cancelled out. But this net force will be, let's call this as F2. F2 will be equal to gm square by 2r whole square, which is 4r square. So the net force on mass m, that is equal to F2 plus 2 F1 cos 45. That is F1 is F2 is gm square by 4r square plus 2 into F1. So this will be root 2, since y cos 45 is 1 by root 2. So 2 into 1 by root 2 is root 2. Root 2 into F1, that is gm square by 2r square. This will be equal to Gm square by 4r square to 1 plus 2 root 2. That would be equal to so this will be equal to m v square by r, m v square by r. So the speed of each particle, that will be, so mv square by r, that is equal to gm square by 4r square into 1 plus 2 into. So m will get cancelled, r will get cancelled. So v will be equal to root over gm by 4r into 1 plus 2 into. So we can say this will be 1 by 2 into root over gm by r into 2 into plus 1. Option B is the correct answer. So here it is told, if RE be the radius of Earth, RE be the radius of Earth, then the ratio between the acceleration due to gravity at a depth r below and the height r above the Earth's surface is r is less than r. R is not much less, but r is less than r. Now, ratio of the acceleration due to gravity at a depth. So GT, that is, we know that G at a depth, we know that it's equal to G on the surface into 1 minus d by r, and G at a height h, that is given as G into r square by r plus h whole square. But G is the acceleration due to gravity on the surface. So now, therefore, we have to find G at a depth r by G at a height r, their ratio. You can call it G dash h. So this will be G into 1 minus r by r by G into r square by r plus r whole square. R is equal to same as R E only. R is the radius of the Earth. G and G will get cancelled. Then we will have, it will be r minus r by r into r plus r whole square by r square. So this will be equal to r minus r into r plus r, that is r square minus r square into r plus r by r cube. Therefore, the required ratio, that is equal to, so we can multiply. So this will be equal to r cube plus r square minus r square r minus r cube divided by r cube. So this will be equal to 1 plus r by r minus r square by r square plus r cube by r cube. Which means that is option D is plus. Okay. So option D is the correct answer. Then here it is told that the masses and radii of the Earth and the Moon are M1, R1, and M2, R2 respectively. Their centers are at a distance r apart. Find the minimum escape velocity for a particle of mass m to be projected from the middle of these two masses. Find the minimum escape velocity for a particle of mass m to be projected from the middle of these two masses. So here we have Earth, here we have Moon, its mass is m1 and radius is r1. Mass of the Earth is m2. Okay, no. Mass of the Moon is m2, radius is r2, and mass of the Earth is m1 and radius is r1. So therefore, from the middle, they are at a distance r apart. So from the middle of these two, a mass m has to be projected so that it it, it, it reach infinity. Means we have to give the escape velocity here. So I will say that the initial kinetic energy plus the initial potential energy, that is equal to the final kinetic energy plus the final potential energy. So final potential energy also will be zero at infinity, and final kinetic energy also will take it as zero at infinity. Since why we need the minimum escape velocity. So therefore, the initial kinetic energy, that is half m square plus the initial potential energy. So that will be one is due to the Earth and one is due to the Moon. So due to the Earth, it will be minus Gm n1 m by r. This is r is equal to actually r by 2. R by 2. And for the Moon, that will be equal to minus G m2 into m by r by 2. This distance will be r by 2, since it is has to be projected from the middle of these two masses. So this is equal to 0. So m on m will get cancelled. So I will say v square by 2 equal to minus 2 g by r into m1 plus, sorry, this will be plus g 2g by r into m1 plus m2. It means v will be equal to 4 root 4, since it will be root over 4g by r, 4g into m1 plus m2 by r. 4g into m1 plus m2 by r. So option D is the correct answer. But here it is told a mass of 50 kg is placed at the center of a uniform spherical shell of mass 100 kg and radius 50 meter. The gravitational potential at a point 25 from the center is E kg per meter. The value of D is mass of 50 kg is placed at the center of a uniform spherical shell. Is a uniform spherical shell. The mass has mass capital M, which is 100 kg. They can call it as 2m. And the mass of 50 kg and small m, that is 50 kg, that is placed at the center of this uniform spherical shell. If the gravitational potential at a point 25, it is having radius r, that is 50 meter. The gravitational potential at a point 25 meter from the center is b kg per meter. The value of b is at this point at r equal to r by 2, which is 25 meter, the value of the net potential we have to find out. So V will be equal to G m by r is minus G m by r, then plus due to the sphere, due to the shell, that will be same as on the surface, will be minus G m by r is equal to minus G into 50 by 25 plus of minus G into 100 by 50. So 50 to is 100, 25 to is 100, 25 to is 50. So this will be equal to minus 2G minus 2G, which is equal to minus 4G. So option D is the correct answer. Then it is told inside a uniform spherical shell, the gravitational field will be zero, it is true. The gravitational potential is zero, it is false. The gravitational field is same everywhere. Gravitational field is same everywhere inside, that is true. Since everywhere it would be zero only, the gravitational potential is same everywhere, that is also true, which is Gm minus Gm by r, which is same on the surface. So only 1, 2, and 1, 3, and 4 are correct. 1, 3, and 4. So option A is the correct answer. And here it is told this will be actually, yeah. Here it is told that two identical particles of mass 1 kg each go around a circle of radius r. Two identical particles of mass 1 kg each go around a circle radius r under the action of their mutual gravitational attraction. 1 kg mass. Mass is 1 kg. Each go around a circle of radius r. The action of their mutual gravitational attraction. The angular speed of each particle is known. So omega we have to find out. So we know that m omega square r, that is the centripetal force, that will be equal to m omega square r, that will be equal to m omega square r, that will be equal to their mutual gravitational force, which is g m square by 2r whole square. So m and m will get cancelled. So omega square, that will be equal to gm by 4r cube. So omega will be equal to root over gm by 4r cube. So which is equal to root over g into m. M is 1 kg, 4 into r cube. It is root over g by 4r cube. or I can say it is 1 by 2 root over g by r cube. 1 by 2 over g by r cube. So option B is the correct answer. Then it is told the planet Mars has two moons. If one of them has period 7 hours 30 minutes and an orbiting radius of 9 into 10 power 3 kilometer, find the mass of Mars. So then we can say that we know that orbital velocity that is equal to orbital velocity that is root over gm by r. So we can say that orbital velocity is equal to 2 pi r by t, that is equal to root over gm by r. If we square both sides, then we get 4 pi square r square by t square, that is equal to gm by r. It means that t square will be equal to 4 pi square by gm, 4 pi square by gm into r cube. Therefore, the mass, if we want to find mass of the planet Mars, that is equal to 4 pi square by g into r cube by t square. That we have to use. Then you can find out the mass of the planet Mars. And 4 pi square by g value has been told 6 into 10 power 11. So in the SI units only they have told 6 into 10 power 11 in the SI units. So the mass of Mars that will be equal to 6 into 10 power 11 into r cube. R is 9 into 10 power 3, so 10 power 6 meters. It's 4 cube. 6 4 cube divided by the time. We have to convert into seconds. So 7 hours plus 30 minutes. So that will be equal to 7 into 3600 seconds plus 30 into 60 seconds. So this will be equal to 7 into 3600 plus 3618 1800 seconds. So this will be equal to 1800 into, I can say 7 to the 14, 14 plus 1, that is 15. This much seconds, so I can say it is 1500, 59 is 120. And then 51 15, so 27,000 seconds. So this is divided by 27,000, so 2.7 to 10 power 4 much whole square. So you have to do, then we get the mass of Mars. So therefore the mass of Mars, that is 6 into 10 power 11 in kg/1. This is 9 into 10 power 6 whole cube divided by 27 into 10 power 3 whole square. It will be 6 into 10 power 11 into 9 to 9 into 9 into 10 power 3 6 18 divided by 27 into 27 into 10 power 6. This will be 9 3s are 27, 9 3s are 27, 3 3s are 9. This will be 6 into 10 power 18 plus 11 minus 6. This will be 6 into 10 power 18 plus 5 is 23. 6 into 10 power 23 kg. So option D is the correct answer. And here it is to consider a planet in some solar system which has a mass double the mass of the Earth. So the mass of that planet is double the mass of the Earth, and the density of that planet is equal to the average density of the Earth. Let's call it as rho. Suppose say if the weight of any object on Earth is W equal to m into g, the weight of the same object on that planet the weight on that planet will be equal to m into g dash. So now g dash will be equal to now it is g m mass of planet by r square, r square. So now g into mass of planet is 4 by 3 pi r p cube into density divided by r p square. This will be equal to G into rho into 4 by 3 pi into RP. So now the density is same. So therefore the G dash is equal to is proportional to the radius only. So therefore now mass is twice. So I can say that from here. Here I can say 4 by 3 pi RP cube into density that is equal to 4 by that is equal to twice of here. This is here I can say that mass of that planet is volume into density 4 by 3 pi RP cube into rho that is equal to twice of mass of Earth which is 4 by 3 pi RP cube into rho. 4 by 3 pi rho that will cancel out. So I can say that RP cube that is equal to 2 RE cube. That means the radius of that planet that is equal to 4 power 1 by 3 times the radius of Earth. That means G dash G is equal to actually G into rho into 4 by 3 pi into R RT. That is the radius of Earth. Then say G dash will be equal to that is G by RE into RP. RP is 2 by 3 times 2, so 2 power 1 by 3 times RE. So RE will cancel, which will be 2 power 1 by 3 times G. So therefore, the weight of that object on that planet will be 2 power 1 by 3 times mg, which is the weight on the Earth. The weight of the same object on that planet will be 2 power 1 by 3 times 1 by 3 times 2 power 1 by 3 times W. So option C is the correct answer. And here it is told the minimum and maximum distances of a planet revolving around the sun are x1 and x2. Minimum and maximum distances of a planet revolving around the sun are x1 and x2 if the minimum speed of the planet on its trajectory is v0, then the maximum speed will be. So we know that the angular momentum will remain constant. So therefore I can say mvr that is remaining constant. So I can say that v1 r1 that will be equal to v2 r2. So therefore I can say the minimum speed will come at the maximum distance. So here it is told v0 is the minimum speed and x2 is the maximum distance from the sun. So at x2 only the velocity will be v0. So I can say v0 x2 that is equal to the maximum speed, let's call it as v2, v max into the minimum distance which is x1. So the maximum speed will be equal to v0 into x2 by x1. v0 into x2 by x1. So option D is the correct answer. Then it is told body is projected vertically upwards from the surface of the earth with a velocity sufficient enough to carry it to infinity. The time taken by it to reach height h is. Body is projected vertically upwards from the surface of earth with a velocity which is sufficient enough to carry it to infinity. The body is projected vertically upwards with a velocity which is sufficient enough to carry it towards infinity. The time taken by it to reach height h is. the time taken by it to reach height h is how much. So now it's projected vertically upwards. So now we can say that the force that is acting downwards, that is mg, the acceleration equal to acceleration is acting downwards, so it will decrease the velocity with each time. So I can say acceleration, which is the retardation. Actually, here the g is actually the retardation, but the retardation is not constant here since it will vary with the height. So the retardation is minus dv by dt. The velocity is sufficient enough to carry it towards infinity. Velocity is sufficient enough to carry it towards infinity. So it has been um, projected with the escape velocity. Escape velocity, as you know, that is v over root 2 gr re. Root 2 gre, since it is v over 2 gm by r. Gm is gr square. So I can say the initial velocity is this. Initial velocity is this. And at height h, the velocity will be v. Height h, the velocity will be v. So I will say that if g at any height, at any x height above, at any x, g is equal to g into r square by r plus x whole square. This will be, so g at the surface, g dash is at the g dash is at the height x. The g r square by r plus x whole square, which is the acceleration due to gravity at the height x, and that is equal to minus dv by dt. dv by dt, or I can say it is acceleration is minus v dv by dx. v dv by dx, simply I can say. Now velocity is going from u to v, initially, so, and x is going from 0 to h. Velocity is decreasing with the height. Velocity is decreasing with x. X is increasing and velocity is decreasing. So I will say it is minus dv by dx. So therefore, I will say that gr square by r plus x whole square, that is equal to minus g dv by dx. Now we have to integrate. Therefore, I will say minus b dv, that is equal to gr square by r plus x whole square into dx. To dx, now integral b will go from ve, that is root 2 gr to v. At a height h, the velocity will be how much? You can conserve the energy also. You can say that to half mv square, the loss in kinetic energy, half mv square minus half mv square, that is equal to the gain in potential energy, which is final minus initial. Final, which is gm m by final value, which is minus gm by r plus h, minus of initial, which is minus gm mm by r. So m will get cancelled, all m will get cancelled. So this is v square minus v square, that is equal to 2gm by r into 1 minus 1 minus r by r plus h. V square, which is 2gr minus v square, that is equal to this is also 2gr to 1 minus r by r plus h. Which means that 2gr minus v square, that is equal to 2gr minus 2gr square by r plus h. So 2gr will cancel, minus minus will cancel, so v square, that is equal to 2gr square by r plus h. Therefore, the velocity at a height h, that is equal to the escape velocity, which is root 2gr into r by r plus h. Root 2gr into root over r by r plus h. This v is going from 0 to h. This is going from 0 to h. With this, if you integrate, this will become v square by 2, which is minus v square by 2, and it will go from root 2gr into root 2gr into root over r by r plus h. And is equal to g r square into this will be, if you take x plus, or if you take it as t, then dx would be equal to dt, or I can take it as y. X plus r is y, so then dx would be equal to dy. Integral dx by x plus r whole square. Okay. So this I can write integral dy by y square. Y will go from r to r plus h. So this would be equal to gr square into this is minus 1 by y. That will go from r plus h. So this will be minus gr square into 1 by r plus h minus 1 by r. So minus minus will get cancelled. So this I can say this will be 1 by 2 into 1 by 2 into v square. So it is 2gh into r by r plus h. Then minus 2gr, that is equal to gr square into, should be r minus h by r into r plus h. Minus h, this will be equal to, so 2 will get cancelled. So this is gr into r by r plus h minus 1 is equal to gr square into minus h by r into r plus h. So r will get cancelled, gr will get cancelled. This I can say r minus h by, okay, same thing is coming. So velocity will come as a function of time as well. So dt by dt. Here v is going from this to this. Here actually v will come as a function of x here. So in place of h, if I put x, then also it will, so v as a function of x. So therefore, we got it as b as a function of x, that is equal to root 2 gr into root over r by r plus x. See, that is equal to dx by dt. The time has been asked, so you can say that dt, that is equal to root 2 g into r dt equals to dx into root over r plus x. X is going from 0 to h and t is going from 0 to t. This time we have to find out. So now if your velocity is coming as a function of x, since here if you put r plus x, then also we will get the velocity as a function of x. So now here I can say root 2 g into r into t, that is equal to 80 is r plus x. So x plus r, if I put it as y, so then dx will be equal to dy, and y will go from r to r plus h. So it will go from r to r plus h root y dy is equal to y power e by 2 y e by 2, which is equal to 2 by 3 into r plus h power 3 by 2 minus r power 3 by 2. Therefore, I can say root 2 g r into t, that is equal to 2 by 3 into r power 3 by 2 into, I can say, 1 plus h by r power 3 by 2 minus 1. R will, this is r into 1 plus r, so here root r will come. So t will be equal to 2 by 3 root over r by 2g into 1 plus h by r power 3 by 2 minus 1. So 2 by 3, 2 by 3, so this will be root 2. So I can say this instead of this root 2 and 2, this will become root 2 there. You can say this will become root over 2 r by g, 1 by 3 into root over 2 r by g into this 1 by 3 root over 2 r by g into 1 plus h by r power 3 by 2 minus 1. So it means that option D is the correct answer. So hope all of you understood the solutions of all these questions. Still any doubts, if you have, please write that in the comments. We shall obviously clarify them. Please install our Sapience education application also. So here it is told a satellite is launched into a circular orbit of radius r around the Earth, while the second satellite is launched into a circular orbit of radius 1.0 r. The percentage difference in the time periods of the two satellites is, we know that t square is proportional to r cube. So I can say that 2 delta t by t, it is equal to 3 delta r by r. That means that the relative change in the radius, that is equal to the percentage change in the time period, that is equal to 3 by 2 times the percentage change in the radius. So therefore, the percentage change in the time period, that is equal to 3 by 2 times the percentage change in the radius. So now here the percentage change in radius, that is equal to 1.02 r minus r by r into 100%. So that is equal to 0.02 r by r into 100%. So that is equal to 2%. So therefore, the percentage change in the time period, that is equal to 3 by 2 times 2%, that is equal to 3%. So there is 3% difference in the time periods of the two satellites. So option D is the correct answer. And here it is told, consider a binary star system of star A and star B with masses M A and M B revolving in a circular orbit of radii RA and RB respectively. If TA and TB are the time period of star A and star B respectively, then there is a binary star, so it means circular orbit of radii RA and RB respectively. Then we can say that T square is proportional to R cube. So I can say that T A by TB, that will be equal to RA by RB power 3 by 2. Option A is the correct answer. Now here it is told, a person whose mass is 100 kg from Earth to Mars travels from Earth to Mars in a spaceship, neglect all other objects in the sky and take acceleration due to gravity and subject Earth and Mars as 10 meter per second square and 4 meter per second square respectively. Identify from the below figures the curve that best fits for the weight of the person as a function of time. So there will be a null point in between Earth and Mars where the net gravity will be zero at that point. So here the weight will be zero. So it means that it will touch the time axis, since at some point the weight will become zero at the neutral point. So it means that option C, the graph C, the curve C is the correct answer. So option D is the correct answer. And here it is told, if the angular velocity of Earth's spin is increased, the angular velocity of Earth's spin is increased such that the bodies at the equator start floating, the duration of the day would be approximately. We know that the acceleration due to gravity at the equator, that is given as g minus omega square r cos square theta. Cos square r cos square theta, where theta is the latitude of that place, and at the equator theta will be 0 degree. So this will be equal to g minus omega square r. So therefore, if this is equal to 0, since it is told the bodies at the equator start floating, so it means g minus omega square r will be 0. So omega square will be equal to g by r. Since omega square r will be equal to g, so omega will be equal to root g by r. So then the angular velocity will increase. So then the duration of the day. So we know that 2 pi by t, it is equal to omega, which is root g by r. So T will be equal to 2 pi root over R by G, which is equal to 2 pi into R, which is 64 into 10 power 5 divided by G, that is 10. So this will be 10 power 4. This will be 2 pi into 8 square root of 68 into 10 power 2. So this is 2 8 is 16, 1600 into 5, that is 3.14. So it is 314 into 16. This is the time in seconds. So therefore, the time in minutes we have to find. So 314 into 16 by 60 minutes. So this will be 2 3 is 6, 2 8 is 16, 4, 2 15 is 30, 2 4 is 8. So this will be equal to 4 4 is 16, 1 is 4 5, 4 is 16, 5, 4 3 is 12, 1 2 5 6, 5 15 minutes. So this will be equal to 15 8 is 120. And 15 4 is 60. So 84 minutes approx. So 84 minutes will be the duration of the day. Option A will be the correct answer. And here it is told the angular momentum of a planet of mass m moving around the sun in an elliptical orbit. There is a planet of mass m moving around the sun. Sun's mass is m. Yes, it is moving in an elliptical orbit. Angular momentum is L. The magnitude of the areal velocity of the planet is So it is equal to mvr. V is the areal velocity. Areal velocity is constant, so I can say areal velocity, that is dA by dt, that will be equal to d by dt of A, that is uh, dA. I can say it is equal to r d theta. dA, that is equal to half into r into r d theta, half r square d theta is half r square d theta, that is r square by 2 omega. Omega. L is equal to I omega is equal to nr square omega. So L by 2m, that is equal to r square omega by 2. So the areal velocity t by dt, that is equal to r square omega by 2, which is equal to L by 2. L by 2m. It means that the areal velocity is L by 2, so option B is the correct answer. Then it is told the time period of a satellite in a circular orbit of radius r is t. The period of another satellite in a circular orbit of radius 9 is. So as we know, t square is proportional to r2. So I can say that t1 square by t square, that is equal to r1 square r1 cube by r cube. Therefore, t1 square, the period of the satellite having radius 9r, that will be equal to r1, that is 9r by r whole cube into t square. R will cancel out. So therefore, t square, that is 9 cube, means 3 power 6 into t square. So therefore, t1 will be equal to 3 power 3 into t, which is 27t. Means the period of the the other satellite having radius 9r will be 27t. So option D is the correct answer. Then here it is told a geostationary satellite is orbiting around an arbitrary planet P at a height of 11r above the surface of P, height of 11r above the surface of P. Then r being the radius of P, it is the radius of this planet P. The time period of another satellite hours at the height of 2r from the planet P. The time period of another satellite in hours at a height of 2r on the surface of P is dash. T has a time period of 24 hours. The geostationary satellite T has a time period of 24 hours. It means the time period of the geostationary satellite will be 24 hours. The height of 11 hours. So it means T square we know that is proportional to R cube. So I can say that T1 square we have to find the time period of this satellite T1. So T1 square by T square that is equal to R1 cube by R cube. Now R1 cube by R cube, small R cube. Now small r, which is the radius of this, the radius of the orbit of the geostationary satellite, which is 11r plus r, that is 12r. And r1 that is equal to 2r, 2r plus r, that is 3r. So therefore, and t is 24 hours. Therefore, I will say t1 square that is equal to r1 that is 3r by r that is 12r whole cube into t square that is 24 square. So t1 square that is equal to r, I will consider 34012 is 4 cube, which is 1 by 64 into 24 square. So therefore T1 will be equal to 24 by 8. 8 3 is 24, which is 3 hours. So therefore the time period of the other satellite, which is revolving at a height of 2r from the surface of the planet P, will be 3 hours. So option A is the correct answer. And here it is told the maximum and minimum distances of a comet from the sun are 1.6 into 10 power 12 meter and 8 into 10 power 10 meter respectively. The speed of the comet at the nearest point is 6 into 10 power 4 meter per second. The speed at the farthest point is the maximum and the minimum distances of a comet from the sun are from this with the speed of comet. So at the nearest point, r will decrease, so the speed will increase. So since we know that mvr is constant, so velocity speed into the distance from the sun, that is equal to constant. So I can say that v1 r1 that is equal to v2 r2. So speed at the nearest point, that is 6 into 10 power 4 meter per second at the nearest point, which is at 8 into 10 power 10. Now the velocity at the farthest point that we have to find out, v2 let's say into r2, that is 1.6 into 10 power 12. Therefore v2 will be equal to 6 into 8 into 10 power 14 divided by 1.6 into 10 power 12. So it is v2 will be equal to 6 8 of 48 10 power 14 divided by 16 into 10 power minus 1 to 10 power 11, so 16 3 of 48. So v2 will be equal to 3 into 10 power 3 meter per second. Option A is the correct answer. And here it is told a planet revolving in elliptical orbit has constant velocity of revolution. It is not true. It's the least velocity when it is nearest to the sun, which is false since when it is nearest to the sun, it will have maximum velocity. Its aerial velocity is directly proportional to the velocity, which is false since why aerial velocity is constant. And aerial velocity is inversely proportional to the velocity, that is also false. Since why aerial velocity, that is dA by dt, that is constant, which is called the law of areas, which is Kepler's second law. Then it is told to follow planet revolving elliptical orbit has to follow a trajectory such that the aerial velocity is constant. Yeah, so it is true. So only E is correct. So option B is the correct answer. And here it is told find the gravitational force of attraction between the ring and sphere as shown in the diagram, where the plane of the ring, plane of the ring is perpendicular to the line joining the centers. Perpendicular to the line joining the centers. If root 8r is the distance between the centers of the ring and the sphere, where both have equal radius r. So the the gravitational field at the point y due to this ring, that will be the gravitational field, and call it G, that is equal to E, I can say, will be equal to E mx, this is root 8r, Gm into root 8r by is r square plus x square, so it is 8r square, r square plus x square power 3 by 2, which will be equal to Gm 8r root 8r, Gm into root 8r by 9r square power 3 by 2. So this will be equal to G into root 8 into r by and 9 power r, that is 3, 3 cube, that is 27, 27 into r power 3. This will be r square. This will be equal to root 8 by 27 into Gm by r square. So therefore, the force that will be equal to m into E, that is equal to root 8 by 27 into Gm by r square. It means that C is the correct answer. Since the sphere will act as if, since this root 8r, I can say this is much more than r. So this mass of the sphere will act as it is uh, concentrated at the center. The entire mass of the sphere will be concentrated at the center of the sphere. So we can say that the net force will be the mass of the sphere at the point y into the electric field into the gravitational field due to the ring at the point y. That you have to do. Instead of E, we can call it a small g also. So m into g. So that is this. And here it is told a solid sphere of radius r. Solid sphere of radius r gravitationally attracts a particle at 3r from its center with a force F1. Now, a spherical cavity of radius r by 2 is made in the sphere, and the force becomes F2. The value of F1 is to F2 is now F1 is the force which it attracts towards it. So that will be m by only g m. So it's here. Now we can consider the density to be uniform. Since it is a uniform solid sphere, we can assume it is force v into m, and now this capital M I can say that is density into 4 by 3 pi r cube. 4 into 4 by 3 pi r cube into small m by r square. This is 3r whole square in the center. This will be equal to 4 by 3 pi rho m 4 by 3 pi rho m g into r cube divided by 9 r square. So this is this. So this will be 4 by 327 pi rho m g r. This is the force F1. Now F2 would be equal to it will attract towards the center of mass somewhere here. Center of mass that will be here. So the center of mass we can find out that will be equal to xcm. xcm that will be equal to m1 is rho into 4 by 3 pi. You can take the volume is 4 by 3 pi r cube into center is at 0, then minus 4 by 3 pi r by 2 whole cube. Center is at r by 2 divided by v1 plus v2. Is v1 minus v2. So this 4 by 3 pi r cube minus 4 by 3 pi r by 2 whole cube. For xcm that will be equal to 0, which will cancel out. 4 by 4 by 3 pi will cancel. So this is equal to minus r power 4 by which is 16 divided by r cube minus r cube by 8, which is equal to 7 r cube by 8. equal to 7 r cubed by 8. So HCM that will be equal to minus r power 4 by 16 into 8 by 7 r cube. So 8 to the 16 r cube, this will cancel. So this is minus r by 14. This is r by 14. So F2 will be equal to that minus r by 14, the center of mass. So this will be G into density into 4 by 3 pi r cube minus this. So the net volume is r cube minus r cube by 8, which is 7 r cube by 8 into G, Gm on M2 by r square. So this is 3r plus r by 14. It's 3r plus r by 14 whole square. So F2 that would be equal to, it is 3r plus r by 14, that is actually 2r. Also 3r plus r by 14, that is 14 3 are 42. So 43, 14 3 are 42. 3r by 14. Or simply you can say this is 3r whole square only, since r by 14 is much less than 3r. This is 3r whole square only, approximately. This is G rho into 4 by 3 pi into 7 by 8 r cube into m by 9 r square. Cancel, so this will be 4 by 3 pi G rho m 4 by 3 pi G rho m r by into 7 by 8, 7 by 9 and just 72. So therefore F1 by F2, F1 by F2 that will be equal to, so this I can write 4 by 3 to 1 by 9. So I can say F1 by F2, this part will get cancelled, 4 by 3 pi G rho mr by 3 pi G rho mr, that will cancel out. This will be 1 by 9 by 7 by 72. This will be equal to 72 by 9 into 7. Measure 72, so 8 by 7. And say this will be so obviously the ratio will be, F1 will be obviously higher, since why in case of F2 the cavity has been formed. So F1 will be obviously higher than F2. So it means that F1 by F2 value should be always obviously more than 1. So the ratio should be more than 1. Should be more than 1. So it means that either A or C, either A or C it will be. If you take 3r minus r by 14, so this will be um, so here F2 that will be equal to subtract that force, since when the mass is taken out, it means it is acting like a negative mass. So we can solve it like this. We can do that F1 that will be equal to, let's say this mass of the sphere is m, and mass of the part which is taken out, that mass m that will be equal to that mass m that will be, I can say, that is m by 4 by 3 pi capital R cube into 4 by 3 pi r by 2 whole cube. This 4 by 3 pi, 4 by 3 pi cancel. This is 1 by 8. This is n by 8. So F1 that will be equal to G m by 3r whole square. Since from the center it is, the distance is here. So it is G m by 9r square. And F2 that will be equal to the force F1 minus the force due to this negative mass. Since why, when it is taken out, it is acting like a negative mass. So minus the force due to this removed mass, which is m by 8. So this is G m by 8 into m by, and its center is at r by 2. So this distance is 2r minus r by 2. That is equal to 2 to the 4. So 3r by 2. 2r plus r by 2. So this is actually 3r, 2r plus r by 2. So that is to the 4, 5r by 2. Is 5r by 2 whole square. So this will be F2 that will be equal to G m by 9r square minus G m by 8 into 25 r square by 4. So 4 is 8. So this is G m by r square into, I can say, this is 1 by 9 minus 1 by 50. It is equal to G m by r square into, this is 5 9s of 45, 45, 50 minus 9, that is 41. Therefore, so F1 by F2 that is equal to F1, that is G m by 9r square divided by G m by r square into 41 by 450. So this will be equal to GM by R square, that will cancel. So this is 1 by 9 divided by 41 by 450. So that is equal to 1 by 9 into 450 by 41. 5 9s are 45. So this is 50 by 41. So the answer is 50 is to 40. Option C is the correct answer. And here it is told two satellites A and B of masses 200 kg and 400 kg are revolving around the Earth at height of 600 kilometer and 1600 kilometer respectively. If TA and PB are the periods of A and B respectively, then the value of TB minus TA is. So TA, that will be equal to the 4 pi square by GM. You can say this is actually orbital speed, that is root over GM by R. So it means that 2 pi R by T, so 4 pi square R square by T square, that is equal to GM by R. That means that 4 pi square R cube, that is equal to GM into T square. Therefore, T will be equal to 2 pi by root GM, 2 pi by root GM into R power 3 by 2. Now root GM is equal to root over GR square. GM, okay. The time period of A, that will be equal to, so the time period is independent of the mass of the satellite. It will depend only on the height. So the radius of A, that will be equal to 600 kilometer plus 6400 kilometer, that is equal to 7000 kilometer. And RB, that the orbital radius of B, that is 1600 kilometer plus 600 400 kilometer, that is 8000 kilometer. So TA, I can say that is 2 pi by root over GM. This G R square, G is 10 into R square. G, capital G is 6.7 into 10 power minus 11. G, I can say 10. R is this, so G is 10 into R square. So into R will come here, root 10. So that is pi, I can say. Root 10 is approximately pi. Pi into 6.4 into 10 power 6 into radius R, that is RA, that is 7007 to 10 power 3 and 4 power 3 by 2. So pi will cancel 3.2. This is equal to 7 power 3 by 2 by 3.2 into 10 power is 9 by 2 minus 6. 4.5. 3r square. 7 power 3 by 2 by 3.2. 10 power 9 by 2 minus 6. This will be the 7 into root 7 divided by 2.2 is 5.7876 into 10 power which is actually 0. 10 power 6 actually is 10 power 6. That's why it is in kilometer. So 2 3 are 6, 6 is a 9. So 9 minus 6 that is equal to 10 power 3. So this much seconds it will come. So it is approximately 5.8 into 10 power 3 seconds. And for 2t, the time period of b that will be equal to 2 by pi into r into this is 7 is 8 into 10 power 6 whole power 3 by 2. This will be equal to 5 will cancel, so 2 by 0.4 into 10 power 6 into 8 power 3 by 2 into 10 power 9. This will be 10 power 3. 2 is 3 is 6. So this is 8 power 3 by 2 by 3.2 into 10 power 3 seconds. So this is approximately 8 power. Okay. 8 root 8, which is actually 8 into root 8 is 22.63 divided by 3.2. Is 7.07 approx. This is approximately 7.071 into 10 power 3 seconds. So therefore TB minus TA, that is 7.07 minus 5.8 to 10 power 3 seconds, which is equal to approximately is approximately 1.27 into 10 power 3 seconds. So approximately I can say 1.33 into 10 power 3 seconds. Option A is the correct answer. And here it is told that given below are two statements, one is labeled as assertion, another one is labeled as reason. Assertion A is the escape velocities of planet A and B are same, but A and B are of unequal mass. The product of their mass and radius must be the same. So M1 R1 equal to M2 R2. R1 equal to M2 R2. And we have unequal mass. The product of, okay, so escape velocity that is given as root over gm, root 2 gm by r. So they have unequal mass, it means they have unequal radius also. It means m by r will be same. Since the escape velocity is same. So it means that m1 by r1 that should be equal to m2 by r2. So it means the ratio of their mass and radius should be same. So the reason is false. The reason is false. And the assertion is true. So it means assertion is correct, but R is not correct. So option C is the correct answer. And here it is told body weighs 49 Newton on a spring balance at the North Pole. What will be the weight recorded on the same weighing machine if it is shifted at the equator? So at the equator, G dash is given as G minus omega square R. Since we at the equator, the angle theta, which is the latitude, that is 0 degrees. So actually for any latitude theta, G value is given as G minus omega square R cos square theta, where omega is the angular velocity of the rotation of the earth. Angular velocity of the rotation of the earth, and R is the radius of the earth. So at the equator, the angle theta, which is the latitude, that is 0 only, 0 degrees. So therefore cos 0 is 1. So it means G dash G at the equator, that will be equal to G minus omega square R. So at the North Pole, at the poles, theta is equal to 90 degree at the North Pole. So therefore G dash will be same as G only. It is so therefore the weight mg, that is given as 49 Newton. So therefore the weight recorded on the weighing machine mg dash at the equator, that will be equal to m into g dash. So that will be m into g minus omega square r, which is equal to mg minus omega square m omega square r. The g is 9.8. So therefore the mass, that is equal to m by g, w by g, weight at the poles divided by g. So that is 49 by 9.8. So I can say 490 by 98. So that is 49 1 10s are 49 2s are, so 2 5s are 10, that is 5 kg. So therefore the weight at the equator, that will be equal to the weight at the poles, that is 49 Newton minus m 5 into omega square, that is omega of the rotation of the earth, which is omega equal to 2 pi by t. So omega square will be 4 pi square by t square. T is for 24 hours. The time period is 24 hours. So 24 into 3,600 whole square. So this will be equal to 4 pi square by 24 into 3,600 whole square into the radius of Earth, which is 6.4 into 10 power 6. Since radius is given in kilometers, so in meters it will be 6.4 into 10 power 6 meters. Therefore, the weight at the equator, that will be equal to 49 minus, obviously it will be less than 49. So only one option is there, which is less than 49. So option C is the correct answer. Then it is told 4 identical particles of equal masses 1 kg made to move along the circumference of a circle. They are made to move along the circumference of the circle. Their masses are m. M is equal to 1 kg. Moving along the circumference of a circle of radius 1 meter. Radius 1 meter under the action of their own mutual gravitational attraction, the speed of each particle will be. So they will form an equilateral triangle, obviously. Will form an equilateral triangle around that circle. The mass is mass m. So their mutual gravitational attraction. So this is R. This is also R. This is also R. This is 120 degrees. It means that this is 90 degree. Now this is 60 degree. This R. So this is 30 degrees. So I can say this length L will be equal to R sine theta. So R r sin 30, that is r by 2. So this length is 3r by 2. So this length, let's call it as x. So x will be equal to actually r cos 30, which is root 3r by 2 into 2. So the x is equal to root 3r actually. X is root 3r. Therefore, the net force, this is, let's say, force F, this is force F. So this is F, this is 30 degrees, this is 30 degrees, so F cos 30, so this is 2F cos 30. The net force at the center on any particle, the net force acting on any particle of mass m towards the center is 2F cos 30, since y F sin 30 and F sin 30 will get cancelled. Sin 30 and F sin 30 will get cancelled. So therefore, the net force over the center, that is 2F cos 30, that is 3 by 2, that is equal to UF into root 3 by 2, UF into root 3 by 2. That is equal to m speed of each particle in mass v. So v is mass. So m is square by r. So 2 will cancel. So root 3f. So f will be equal to gm square by x square, which is x is root 3r. So root 3r whole square, which is 3r square. So root 3 into gm square by 3r square, that is equal to mg square by r. R will get cancelled, m will get cancelled. So v square, that is gm by root 3r. So v will be equal to, okay, 4 identical particles are there. 4 identical particles which will form a square. 4 identical particles that will form a square in the circle. So the net force acting, that is, one is m, this is m. So mass is 1 kg and the radius is also, radius of the circle is 1. So this is 1. So this length will be how much? This is 1. This is 90 degrees. So this is root 2. Okay. This is also root 2. This is 2. From here to here, it is 2 meters. So the net force acting on each mass, that is equal to gm square by 2 square plus, that is gm square by root 2 square, that is 2 into this 2. Since by this force F, this force, if it is F and this is F1, then the net force acting on any mass m, that is equal to 2F cos 45 plus F1. So this is 2 into F cos 45, which is 1 by root 2 plus F1, which is this. So F will be equal to G into 1 square, which is 1 only, and G by 4 plus 2 and 2 will cancel. So G by root 2, that is equal to m v square by r. R is 1. So v square, that is equal to G by 4 into 1 plus, this is 1 plus 2 root 2. Since by into 2 root 2 if I do, then only it will be 4. So v will be equal to 1 by 2 root over g into 1 plus 2 root 2. So option D is the correct answer. Then here it is told, consider two satellites S1 and S2 with periods of revolution 1 hour and 8 hours respectively. Revolving around the planet in circular orbits, the ratio of angular velocity of satellite S1 to the angular velocity of satellite S2 is So angular velocity of S1 by angular velocity of S2, that is R. So that is 2 pi by T1 by 2 pi by T2. That is equal to T2 by T1. T2 by T1. So T2 is 8 hours and T1 is 1 hour. So that is equal to 8:1. So option B is the correct answer. Then it is told two stars of masses M and 2M at a distance d rotate about their common center of mass in free space. The period of revolution is, so the period of revolution has to be found. So the mass, center of mass, this is at M, center of mass is, let's say, at a distance x r from M, and from 2M, the distance will be how much? Which is why we can say if the center is at the origin at x equal to 0, then we can say that m into minus r plus 2m into, let's say this is x1, 2m into x1 by m plus n, 3m plus 2 into 0. So I can say that 2m x1 that is equal to that is equal to m naught. So x1 will be equal to r by 2. So this will be equal to r by 2. So the common center of mass of the two stars will be at a distance r from M and at a distance of r by 2 from Q. So the time period of revolution, so therefore I will say that T is equal to 2 pi by root gm to r power 3 by 2, we know this. So T is equal to 2 pi by root gm where the mass at the center, that will be the total mass of the two star, that is 3m, that is root g into 3m into r. R is two stars of masses n and 2m at a distance d. So at a distance d, it means that r plus r by 2, that is equal to g. So it means that 3r by 2, that is equal to d. Plus r will be equal to 2d by 3. So t will be 2 pi by root g into 3m into time period, that is time, the period of revolution. Simply we will say that the net gravitational force acting in between them, this distance is d. This is g into 2m into m, g m1 m2 by r square, that is d square, that is equal to m into v square by r. m into v square, this will be, or I can say m omega square into r. R is equal to 2d by 3. So m will get cancelled and 2 and 2 also will get cancelled. So it means gm by d square, gm by d cube into 3, dgm by d cube, that is equal to omega square. So it means that omega, that will be equal to root over 3 gm by d cube. It means that 2 pi by t, that is this, root over 3 gm by d cube. It means that the time period will be equal to 2 pi into root over d cube by 3 gm. 2 pi into 2 pi into d cube root over d cube by 3 gm. So option D is the correct answer. Since here what we did that the net gravitational force acting on the mass m, that is equal to the net centripetal force acting on the mass m, which is centripetal force, we know, that is equal to m omega square. R, and that is equal to the gravitational force acting on Earth. And here it is told two satellites revolve around a planet in coplanar circular orbits. Two satellites revolve around a planet. Two satellites revolve around the planet in coplanar circular orbits in anticlockwise direction. Their periods of revolutions are 1 hour and 8 hours respectively. The radius of orbit of the nearer satellite is 2 into 10 power 3 kilometer. The angular speed of the farther satellite as observed from the nearer satellite at the instant when both the satellites are closest is pi by x radian per hour, where x is. We can say that t square is proportional to r cube. We can say that t1 square by t2 square, that is equal to r cube by r2 cube. So the time period of the first orbit is 1 hour and the another one is 8. So whole square, that is equal to, for the nearer one, the time period will be 1 hour. Radius is 2 into 10 power 3 whole cube divided by r2 cube. So r2 cube, that is equal to 2 into 10 power 3 whole cube, 2 into 10 power 3 whole cube into 8 square is 2 power 3, 2 power 6. Is that R2 will be equal to 2 into 10 power 3 into 2 power 2, that is 4. So this is 8 into 10 power 3 kilometer. Then the angular speed of the farther satellite is observed from the nearer satellite when both the satellites are closest. So they both are closest. One is moving with omega 1, one is moving with omega 2. So therefore, the relative angular speed of the second satellite with respect to the first one, speed of the farther satellite as observed from the nearer satellite. Omega 2 1, so that will be equal to 2 pi by omega 1 will be higher since time period is lesser. So omega 1 we have to do. So 2 pi by T1 is less. 2 pi by T1 minus 2 pi by T2. So this will be equal to 2 pi into 1 by T1 1 hour velocity we have to do. So relative angular velocity, that is equal to relative velocity by their distance of separation, that is R2 minus R1. That we have to do. Angular speed of the farther satellite, so that is V relative, that is R omega, R2 omega 2 minus R1 omega 1 divided by R2 minus R1. This we have to do. So therefore, for omega relative, that is the relative angular velocity, angular speed, relative angular speed, the relative angular speed relative angular speed, that will be equal to omega 2 R2 minus omega 1 R1 divided by R2 minus R1. This will be omega 2, that is 2 pi by t into R2 minus 2 pi by T1 into R1 divided by R2 minus R1. This will be 2 pi into R2 by T2 minus R1 by T1 divided by R2 minus R1. This will be 2 pi into R2. R2, that is 8 into 10 power 3 divided by T2, that is 8 hours, minus R1, that is 2 into 10 power 3 kilometer, okay, divided by 1 divided by 8 minus 2 into 10 power 3. This will be 2 pi 10 power 3 will cancel, we get cancelled. So 8 by 8 is 1. 1 minus 2. So we have to take the mod of this, actually, mod of this. So 2 pi into 2 minus 1 divided by 6. This is 1 by 6. So 1 by 6 into 2 pi. So that is equal to 5 by 3 radian per hour. Since y is 8 hour and 1 hour, this is, so it is 5 by 3 radian per hour. So 5 by 3, that is equal to 5 by x. So x is equal to 3. So 3 is the answer. And here it is told body of mass 2n splits into 4 masses m, m minus m, and m minus m, which are rearranged to form a square as shown. The ratio of m by m for which the gravitational potential energy of the system becomes maximum is of x's. So the potential energy of the system, that is equal to, I will say, the first mass which is brought, that is, let's say, m minus m. First mass that is brought from infinity, that is m minus m, suppose. For this, the work done is 0, then m, small m is brought, so therefore the work done will be minus gm into m minus m by the length is d by t. Then minus, so this will be brought, then it will be minus gm into minus m by d minus gm minus m whole square by, this will be root 2d, root 2d. Then minus this will be brought, so this is gm into minus m by d into 2. Then minus gm square by root 2d. So therefore, net potential energy, that is minus gm into m minus m by d into 4. And this will be minus gm minus m whole square by root 2d. Then minus gm square by root 2d. So this is the required gravitational potential energy of the system, and this has to be minimized. This has to be minimum. The ratio of m by n. So m by m has to be x by 1 if potential energy has to be minimized. So m by m is x. So m is equal to mx. So the potential energy of the system, I can say that is equal to minus 4 gm square by d into, this will be mx minus m, that is m into x minus 1. minus this is also g into m square by root 2d into x minus 1 whole square. Then minus this is gm square by root 2d. So this I can say this is minus gm square by d into 4 into x minus 1 plus x minus 1 whole square by root 2 minus 1 by root 2 plus 1 by root 2 m square by 2. So this has to be minimized. So it means let's call this as a function u of x. So therefore, for minimizing du by dx, that has to be equal to 0, and d square u by dx square, that has to be more than 0 if u is minimum at x. Value of x has to be found. So du by dx, therefore du by dx, that will be equal to d by dx of minus gm square by d into this is 4 into x minus 1 plus x minus 1 whole square by root 2 plus 1 by root 2. So therefore, this will be equal to, this should be equal to 0. So that means that d by dx of 4 into x minus 1 is d by dx of x minus 1 whole square by root 2 plus 0, that will be equal to 0. So this will be 4 plus this is 1 by root 2 into 2, 1 by root 2 into 2 into x minus 1. It is equal to 0. Therefore, I can say root 2 into x minus 1, that should be equal to minus 1. Where d 2 into x minus 1. Equals x minus 1, that should be equal to minus 2 root 2. That should be equal to 1 minus 2 root 2. First we can maximum. So d square by d x square should be less than 0. Okay, so here d by dm that should be equal to 0 at square. So for maxima, I can say that d by dm of the potential energy of the system that should be equal to 0. Therefore, I would say that is it means that d by dm of minus 4 gm g by d to m into m minus m minus okay, mm, g into m minus m whole square by root 2d minus gm square by d root 2d that should be equal to 0. So it means that g by d I can minus g by d I can cancel. So d by dm of 4 into mm minus m square then plus d by dm of m minus m whole square by root 2 plus d by dm of uh, m square by root 2 that should be equal to 0. So it means what? It means that therefore 4 into 4 into d by dm of this. So this is m minus 2m plus this is 2 into m minus m by root 2 by root 2 into m minus m into this will be d by dm of this. So this is 0 minus 1. Plus this will be 1 by root 2 into 2m. That should be equal to 0. Therefore, we say 4 into m minus 2m plus root 2 into m minus root 2 into m minus n plus root 2m, that will be equal to 0. Therefore, I can say 4m minus 8m minus root 2m minus root 2m plus root 2m plus root 2m. So this will be 2 root 2m, that is equal to 0. So I will say that 4 minus root 2 into capital M, that is equal to 8 minus 2 root 2 into M. It means that M by M, that is equal to 8 minus 2 root 2 by 4 minus root 2. It means this is, I can take 2 as common, so 2 into 4 minus root 2 by 4 minus root 2. So these 2 will get cancelled, so M by M should be equal to 2. So 2 is the answer. So the value of X should be 2. And here it is told, suppose 2 planets in spherical shape in radii r and 2r, but mass m and 2m and 9m respectively have a center to center separation 8r. Center to center separation is 8r as shown in the figure. A satellite of mass m projected from the surface of the planet m directly to the center of the second planet. The minimum speed v that is required for the satellite to reach the surface of the second planet is a by 7 into root over a by 7 into gm by r, and the value of a is the 2 planets are fixed in their position. So we have to reach the neutral point. If it can reach the neutral point, then due to inertia of motion, it will automatically reach the surface of uh, the planet with radius 2r. So the neutral point we have to find out, which is at a distance x from the mass m. So we can say that here the net gravitational force will become 0. So I can say that Gm here, let's say the mass m. So Gmm by x square, that should be equal to G into 9m into m by 8 r minus x whole square. So 9m into, so m will get cancelled, m will get cancelled, g will get cancelled. So 1 by x, or I can say 9x square, that is equal to 8r minus x whole square. So if we square root, take the square root on both sides, then we will get plus or minus 3x, that is equal to 8r minus x. So it means that x plus or minus 3x, that is equal to 8r. So now we cannot take the negative one, since by x can't be negative. So therefore x plus 3, that is 4x, 4x is 8r, so therefore x should be equal to 2r. So at a distance 2r only, it has to reach. Here the velocity should be 0. So I will say that the loss in kinetic energy is equal to the gain in potential energy. Loss in kinetic energy is so half mv square minus 0. So initial kinetic energy minus final kinetic energy, that is equal to the gain in potential energy, which is u final minus u initial. So the final potential energy at this point, at the neutral point that we have find out. So this length is 6r. This length is 2r. So it means that it will be final potential energy, that is minus g m into m by 2r and minus g m into 9m by 6r. Cm into 9m, Cm into 9m by 6R. Into 9m by 6R minus the initial potential energy, which is minus GMM by R minus GM into 9m by this length, which is 8R minus R, that is 7R. Therefore, I can say half mv square, that is equal to, this will be equal to G mm by R plus Gm into 9m by 7R minus G, this is 3 and 9, 3 is 6, so this is minus Gmm by 2R minus 3Gmm by 2R. So therefore, all the m I can cancel out, small m I can cancel out. So therefore I can say this will be v square by 2, that is equal to Gm by R into Gm by R into 1 plus 9 by 7 minus half minus 3 by 2. So therefore, I can say v square will be equal to 2Gm by R into the LCM of this will be 7 to the, okay, this will be actually half minus 3 by 2, that is minus 4 by 2, which is actually minus 2. So 1 minus 2, so this is actually 9 by 7 minus 2 actually. This is 9 by 7 minus 2, so this is 9 by 7 minus 1. T square, that will be 2Gm by R into 2Gm by R into, this will be 2 by 7. If 9 by 7 minus 1, that is 2 by 7. So v square is equal to 4 by 7 into Gm by R. So that means v will be equal to root over 4 by 7 into Gm by R. So therefore, here it is told root over a by 7 into Gm by R. So a is equal to 4. 4 is the answer. Then here it is told the radius in kilometer to which the present radius of Earth to be compressed, so that the escape velocity is increased 10 times. So that we know that the escape velocity is given as root over 2 Gm by R. So the escape velocity has to be increased to 10 times, 10 V. That means VE dash, that will be equal to root over G2 Gm by R dash. So it means 10 VE, that is equal to root over 2 Gm by R dash. It means I can 10 V means 10 into 2 Gm by R, that is equal to root over 2 Gm by R dash. If we square both sides, then we will have 100 into 2 Gm by R is equal to 2 Gm by R dash. The 2 Gm will cancel, so I can say 100 R dash, that is equal to R. Also, R dash should be equal to R by 100. So in order to increase the escape velocity to 10 times, the radius should be decreased by 100 times. So therefore, the new radius should be 64 kilometer, which is R by 100. So the radius should be 64 kilometers. So 64 is the answer. Then here it is told, if one wants to remove all the mass of the Earth to infinity, okay. Okay, so here it is told, if one wants to remove all the mass of the Earth to infinity in order to break it up completely, The amount of gravitation, the amount of energy that we should supply will be x by 5 change per r when x is. So you know that the gravitational binding energy of a solid sphere, gravitational binding energy, or it is also called the gravitational self energy of a solid sphere, that is given as minus 3 by 5 gm square by r. So it means this much of positive energy would be required to remove all the mass of the earth to infinity. So hence 3 by 5 gm square by r is the energy required. So it means x will be equal to 3. So 3 is done. Here it is told in the reported figure of the earth, the value of acceleration due to gravity same at point A and C, same at point A and C, but it is smaller than of its value, but it is smaller than that of its value at point D. Differential gravity is same at point A and C, but is smaller than point B. The value of OA is to OB, will be access to 1. So here, the value of the test, it means acceleration due to gravity. So at a height that is equal to g into r square by r plus e whole square. So here the height is the radius of the earth, r by 2, the half of the radius of the earth. So it is g r square by r plus r by 2, so 3r by 2 whole square. So this is equal to 4 by 9 into g r square by r square. So this r square will cancel, so this is 4g by 9. So at a depth, the value of g is given as g into 1 minus g by r, that will be equal to 4g by 9. So g will cancel out, so it means 1 minus d by r, that is equal to 4 by 9. It means d by r, that will be equal to 1 minus 4 by 9, which is 5 by 9. It means d will be equal to 5 r by 9. So therefore, OA, since y AB length is 5 r by 9, so therefore OA will be r minus 5 r by 9 is equal to 4 r. Is equal to 4 by 9 times the OA is 4 r by 9, and so AB is 5 r by 9. So therefore OA is to AB. That will be equal to 4 r by 9 is to 5 r by 9. That is equal to 4 is to 5. So therefore the value of x is 4. So is that. And y value will be 5. Y is not asked. Only x is asked. It is told the initial velocity vi required to project a body vertically upward from the surface of the earth to reach a height of 10 r, reach a height h of 10 r, where r is the radius of earth, may be described in terms of the escape velocity, so that vi is equal to root over x by y into v, so the value of x will be. Therefore, it will reach height 10 r. So it means here the velocity will be 0, final velocity will be 0. So the final kinetic energy will be 0. And the initial kinetic energy is half m vi square. So now, therefore, we can say that the loss in kinetic energy, that is equal to the gain in gravitational potential energy. The loss in kinetic energy is kinetic energy initial minus kinetic energy final, that is equal to the final potential energy minus the initial potential energy. So initial kinetic energy is half mvi square and minus 0, that is equal to the final potential energy, which is minus gm m by r plus h, which is 11 r minus minus gm m by r. minus gm by r. Now, escape velocity VE, we know that is equal to root over 2 gm by r. So in terms of VE, we have to find here. So m we can cancel out. Then we will get Vi square by 2, that is equal to Gm by r minus Gm by 11r. It means Vi square by 2, that is equal to LCM will be 11r, and this will be 11 Gm minus Gm. So this will be, so therefore Vi square by 2, that will be equal to 10 Gm by 11r. 10 Gm by 11r. So therefore Vi square, that is equal to 20 Gm by 11r. 11r. So Vi will be equal to root over 20 Gm by 11r, which I can say this is equal to root over 10 by 11 into root over 2 Gm by r. So root 2 Gm by r is the escape velocity. So I can say Vi is root over 10 by 11 into E. So this is the required initial velocity. So which is x root over x by y into VE. So x is equal to 10 and y is 11. But only x has been asked, so 10 is the answer. So I hope all of you have understood the solutions of all these questions based on the previous year JEE mains exam. Still any doubts you have, please write that in the comments. We shall obviously clarify them. And please install our Sapience education application also, which shall be obviously helpful for your exam. So thank you everyone. Bye.